100 kilometers above the planet's surface lies a line no one can see, yet every explorer dreams to cross. It is called the Kármán line, the invisible border between Earth and the infinite. Beyond it, air thins into vacuum. Silence replaces the familiar whisper of wind, and every human heartbeat becomes a symbol of defiance against gravity itself. For more than 6 decades, humankind has been reaching for that threshold. Sometimes with triumph, sometimes with tragedy, always with wonder. This is not just the story of machines or rockets. It is a chronicle of obsession, of thousands of minds and hands united by a single question. How far can we really go? From the first trembling footsteps of Yuri Gagarin to the precise, robotic choreography of the International Space Station, humanity has turned the dream of flight into a permanent presence in orbit. Yet, behind every mission patch and televised launch lies another, lesser-known story, one of isolation, training, and relentless endurance. To become an astronaut is to dedicate your life to preparation for a moment that may never come. Inside specialized facilities, underwater, underground, and deep in the deserts of Earth, men and women simulate the impossible. They spend years learning to live where no life was meant to exist. Every procedure, every emergency, every failure is rehearsed 1,000 times. And still, nothing can truly prepare them for the silence of space. Chris Hadfield, the first Canadian to walk in orbit, once said, "An astronaut's life is one of anticipation and simulation, and almost never about flying in space. Yet it is that fraction of a moment, the brief crossing of that unseen line, that defines a lifetime." The race for space has evolved from Cold War rivalry into a collaboration of nations and corporations. Engineers in Houston, pilots in Cologne, scientists in Moscow, technicians in Tokyo, all bound by invisible threads of trust and calculation. Their world is measured in decimals and trajectories, yet driven by emotion, courage, fear, awe. Behind the polished press releases and televised countdowns, there exists a human heartbeat, one that beats faster as the engines ignite, as the ground trembles, and as the sky opens to swallow another soul into the dark. But as we master the science of leaving Earth, a new question arises. What lies beyond orbit? What happens when the limits of technology collide with the limits of human endurance? For decades, space was a destination. Now, it is becoming a departure point, a staging ground for dreams even larger than the moon. The next frontier is not just the void above us, but the long red horizon of Mars, a planet that mirrors our own, both alien and familiar. The journey there will not be easy. It will demand everything we have learned, and more. This story is about the people who dare to try, the engineers who reimagine rockets, the scientists who reinvent life support systems, and the explorers who accept that the path to the stars is paved with failure and flame. It is about humanity's greatest experiment, to become a species no longer bound to one world. Beyond the blue atmosphere, a silent expanse awaits, and as our rockets roar to life once more, the question echoes louder than ever. Are we ready to leave home? Part 1. The making of an astronaut. 100 kilometers may seem like a short climb, but for those who dream of reaching it, the journey begins years before the countdown ever starts. Becoming an astronaut is less about flying into space than surviving everything that happens on the way there. Behind every mission patch and smiling photo on launch day are thousands of hours of training, isolation, and sacrifice, all to prepare a human body and mind for a place no one was designed to live. At the European Astronaut Center in Cologne, Germany, trainees start their path to orbit with the basics: engineering, emergency protocols, and spacecraft maintenance. They learn to repair oxygen filters, operate robotic arms, and understand every circuit of the International Space Station. Here, mistakes are not failures, they are lessons carved into memory. Each day, the pressure builds as candidates face the same unspoken truth. Very few will ever make it past this stage. Astronaut selection is not about strength or heroism. It's about endurance, physical, mental, emotional. Candidates are tested in caves, underwater, and in isolation chambers that mimic the loneliness of orbit. They live side by side for weeks, navigating darkness, exhaustion, and the strange psychology of confinement. In those moments, space feels closer than ever, not as a destination, but as a presence pressing against the limits of their patience and trust. As one trainee said after returning from the Sardinian Caves mission, "You think you're learning to live underground, but what you're really learning is how to live with yourself." In Florida, beneath the ocean's surface, lies another classroom, the Aquarius habitat. NASA's NEMO program transforms divers into astronauts, teaching them to perform spacewalks in the neutral buoyancy of the sea. For 6 hours at a time, they move through a simulated space station, repairing mock solar arrays and practicing emergencies. Underwater, light bends and sound vanishes. It feels eerily close to the silence of orbit. The weight of the suit, the resistance of the water, the limited field of view, all prepare them for the moment they'll open a hatch and step into nothingness. At NASA's Johnson Space Center in Houston, Texas, the world's largest indoor pool houses a full-scale replica of the International Space Station. It is the Neutral Buoyancy Lab, a cathedral of metal and silence. Here, astronauts spend entire days submerged, rehearsing missions that may never happen. In the water, the difference between precision and disaster is a single misplaced bolt. Every motion is recorded, every error analyzed. The human body tires, the mind is pushed beyond its limits. But as one instructor reminds them, fatigue is part of spaceflight. If you can't think when you're tired, you can't think up there. Outside the water, the training continues in simulators that reproduce the ISS in breathtaking detail. Crews rehearse every possible scenario: fire, decompression, system failure. They memorize every sound, every warning light. In one exercise, the alarm blares, smoke detected in Node 2. 6 astronauts scramble to isolate the section, sealing hatches, rerouting power, reading checklists out loud and calm, clipped voices. It is a performance repeated hundreds of times. The goal isn't perfection, it's instinct. When something goes wrong 400 kilometers above Earth, instinct is all they'll have. Language barriers add another challenge. Every astronaut must train in Russia, mastering not only the Soyuz spacecraft but also the language that controls it. Inside the Star City complex near Moscow, Russian instructors shout commands in rapid-fire Cyrillic. The manuals are all in Russian, the buttons labeled in acronyms. Each trainee learns to think and react in another tongue, because when you're strapped inside a capsule atop a rocket, there's no time to translate. Training stretches on for years. The schedule is relentless. Houston, Moscow, Tokyo, Cologne, sometimes 3 continents in a single month. Families fade into background noise. Home becomes a memory glimpsed between flights. You live out of a suitcase, one astronaut says, and every airport feels like a launch pad. Yet despite the exhaustion, every candidate shares the same quiet gratitude, the knowledge that they are preparing for something far bigger than themselves. And then comes the simulation. Final exams for astronauts aren't written on paper, they're performed in steel and flame. Inside the Soyuz and SpaceX simulators, crews run through full mission profiles, from launch to docking to re-entry. Everything must be second nature. Reading pressure gauges, responding to radio loss, recovering from engine failure. Instructors monitor every heartbeat, every hesitation. The smallest mistake can mean the difference between assignment and rejection. But when the simulation ends and the mock capsule lands, there's a brief moment of silence and then applause. For now, they've survived the rehearsal. The real test still waits. It takes roughly 5 years to train a crew for a 6-month mission aboard the ISS. 5 years of repeating the same drills, of learning how to think in zero gravity, of trusting strangers with your life. Yet when they finally board that rocket, every sacrifice, every sleepless night, every bruise and failure, crystallizes into a single truth. They are no longer earthbound. To cross the Kármán line is to step beyond the limits of human certainty. But to reach that point, one must first conquer something far greater, the limits of oneself. Part 2, training for the impossible to most of us. The image of an astronaut floating outside the International Space Station seems almost serene, a human figure adrift among the stars, tethered to nothing but a lifeline and faith in physics. Yet behind that moment of beauty lies the most dangerous, demanding training ever devised. Spacewalks, or EVA's extravehicular activities, are not elegant ballets in zero gravity. They are battles against time, fatigue, and the unforgiving vacuum of space. At NASA's Johnson Space Center in Houston, the Neutral Buoyancy Lab is where these battles begin. Inside its colossal pool, the size of a football field and 12 meters deep, a full-scale replica of the ISS rests beneath the water. Here, astronauts spend up to 6 hours at a time underwater, rehearsing spacewalks in slow, methodical detail. The suits weigh nearly 130 kilograms on Earth. Underwater, they achieve neutral buoyancy, giving a sensation close to weightlessness. Yet it's not comfort they seek, it's discipline. In that silent blue world, they must learn to move with precision, their hands encased in pressurized gloves that fight every motion. A misplaced tool or a snagged tether can cascade into catastrophe. They practice changing filters, replacing panels, handling unexpected leaks, all while their instructors monitor oxygen levels, heart rates, and communication clarity. After each session, they surface exhausted, trembling from both exertion and concentration. And then they do it again the next day. The repetition is deliberate. Space is not a place for improvisation. Every move must be rehearsed until it becomes instinct. When something fails during an EVA, there is no rescue team waiting beyond the hatch. As one veteran instructor reminds every trainee before they descend into the water, if you panic down here, you drown. If you panic up there, you die. Across the ocean, in Cologne, Germany, the European Astronaut Center has its own pool, smaller, quieter, and equally punishing. Here, candidates train for European-built modules of the ISS, learning maintenance, emergency procedures, and tether operations. They simulate solar panel repairs and practice responses to depressurization alarms. Every second counts. Every gesture must be deliberate. Even communication becomes an art form, the language of calm under pressure. The same lessons are taught in Japan, where JAXA's Tsukuba Space Center trains astronauts to operate the Kibo Laboratory, one of the ISS's most sophisticated research modules. The Japanese instructors are polite but precise. Their tone may be gentle, but their expectations are absolute. Each astronaut must master not just technical operations, but also the cultural choreography of collaboration, how to lead, how to listen, how to synchronize decisions in silence. In orbit, teamwork is survival. And then there's Star City. Hidden in the forests outside Moscow, it remains one of the oldest and most revered astronaut training facilities in the world. The air smells faintly of oil and frost, the walls lined with portraits of Gagarin and Tereshkova. Inside, the simulators for the Soyuz spacecraft await every trainee bound for the ISS. Here, astronauts must learn the Russian systems by heart. Every switch, every light, every warning tone. The manuals are written in Russian. The commands shouted through the speakers are rapid and absolute. When they climb into the capsule, it feels like stepping into history itself. A fusion of analog dials, leather straps, and cold metal that has carried humans into orbit for over half a century. Training in Star City is rigorous and ritualistic. Astronauts repeat launch sequences until they can recite them in their sleep. They learn to handle emergencies blindfolded, to reset systems after simulated power failures, to land a Soyuz capsule in the Siberian tundra. The simulators tilt, spin, and vibrate, replicating the violent turbulence of launch and re-entry. After each session, they emerge drenched in sweat, muscles sore, ears ringing, and yet smiling, because every discomfort brings them one step closer to space. But physical training is only half the challenge. The mind must be tested too. Astronauts endure months of psychological trials, isolation chambers, simulated delays in communication, and even planned conflicts within the team. They are observed constantly. how they react to stress, to silence, to boredom. A moment's loss of patience on Earth could mean a fracture in the chain of trust in orbit. And in space, a fractured team can be more lethal than any technical failure. Extreme environments play a crucial role in this mental conditioning. NASA's NEMO missions place astronauts in Aquarius, an underwater habitat off the Florida coast, where they live for days in confinement, performing mock repairs outside the habitat as if they were in orbit. In these conditions, time stretches. The ocean outside the porthole becomes a metaphor for the cosmos. Vast, indifferent, and always watching. When communication with the surface is delayed, when equipment malfunctions or oxygen levels dip, they must rely solely on training and each other. It is here many astronauts say that they first feel truly alone and truly prepared. Then there are the caves. In Sardinia, the ESA's Caves program sends astronauts deep underground, into labyrinths of stone and darkness. For a week, they navigate the subterranean world without sunlight, mapping new passages and surviving with limited resources. The caves mimic many aspects of space: isolation, disorientation, and dependence on teamwork. It's a reminder that exploration, whether underground or beyond the atmosphere, always demands humility before the unknown. All of this training, from Houston to Moscow, serves one purpose: to prepare humans for an environment that will never welcome them. Astronauts learn to live with constant tension, the awareness that every heartbeat is measured, every breath recycled, every mistake magnified. Yet, paradoxically, they also learn peace. Floating weightless, tethered by nothing but trust, they discover something deeper than fear, a sense of belonging in the impossible. Years of repetition, simulation, and endurance all lead to a single moment: the sound of engines igniting beneath them. As the countdown reaches zero, everything they've learned collapses into instinct. No more drills, no more instructors, just the roar of fire, the pull of acceleration, and the fading blue of Earth beneath their feet. For those few who make it this far, one truth becomes clear: space is not conquered by rockets. It is conquered by resolve. Part 3, Crossing the Line. Into orbit, the countdown begins in a language older than spaceflight itself. The rhythm of breath, the pulse of adrenaline, the silent exchange of glances between crew members who know this is the moment everything has led to. Around them, the rocket hums like a living creature. Its body, stacked with thousands of tons of fuel, waits to burn itself into history. When the engines ignite, the world outside vanishes in a blur of flame and vibration. Inside the capsule, there is no sound, only pressure, the violent shaking of metal, and the rising roar of Earth letting go. The Kármán line, the invisible threshold between air and nothing, flashes past in seconds. A lifetime of gravity disappears in a single moment of silence. For the first time, the astronauts are weightless. Pens float, straps drift. The human body, so long anchored to the ground, finally forgets how to fall. 0G. The commander calls out, voice trembling between disbelief and relief. The crew laughs, a burst of sound that feels like sunlight in the dark. The first moments of orbit are a paradox: absolute freedom and total confinement. Outside, the small porthole stretches a horizon unlike anything seen on Earth. A thin blue arc, delicate as glass, curving against the black infinity beyond. In that instant, every sacrifice, every repetition, every night spent dreaming of this view suddenly makes sense. Docking with the International Space Station is a dance measured in millimeters. Approaching at just a few centimeters per second, the spacecraft aligns itself with the orbital outpost, a gleaming web of solar panels and modules gliding silently 400 kilometers above the world. The tiniest miscalculation could send the vehicle tumbling away into the void. Inside, astronauts monitor the approach with steady hands, reading numbers that translate into trust. When the clamps finally engage and the hiss of pressurization fills the cabin, there's a brief pause. Then the hatch opens, and the smell of the station's recycled air greets them like a familiar stranger. The ISS isn't what most imagine. It isn't sleek or futuristic. It's a labyrinth of cables, labels, and humming machinery. Part laboratory, part home, part cathedral to human endurance. Every surface is covered with tools, handrails, and Velcro patches to keep objects from floating away. Every sound, the whir of pumps, the hum of fans, the soft chatter of mission control, becomes a heartbeat that fills the silence of space. For the first few hours, the new arrivals float awkwardly, learning how to move without falling. Muscles and instincts built over a lifetime no longer make sense. To travel forward, they push gently off a wall. To stop, they grab a handhold. The absence of gravity turns every motion into a dance of patience. Even a drop of water behaves differently, forming perfect spheres that drift through the air like tiny planets. Life aboard the ISS is a symphony of schedules. Every minute is planned. Experiments, maintenance, exercise, sleep. Astronauts become both scientists and caretakers, conducting research on everything from protein crystallization to the behavior of flames in microgravity. Each task adds to the growing library of knowledge needed for the next great leap, the journey to Mars. But even amid the constant motion, there are moments of stillness that remind them why they came. At night, though night is a strange concept when the station circles Earth every 90 minutes, they gather by the cupola, a dome of windows overlooking the planet. Below, storms swirl across continents, cities sparkle like neural pathways, and the horizon glows with shades of blue and gold. From here, borders vanish, politics fade. The world becomes a single, fragile sphere, wrapped in a paper-thin layer of air. It is both infinite and impossibly small. For all its wonder, orbit is never without danger. Every sound, every flicker of a warning light can signal disaster. A micrometeorite strike, a sudden loss of pressure, a solar flare. Any one of these could turn the station from sanctuary to coffin. But the astronauts have trained for this. Their minds run on procedure and instinct. When an alarm sounds, they move like choreography, sealing hatches, donning masks, checking systems. Fear becomes focus. Panic has no place here. Communication delays mean that sometimes they are on their own. Ground control can advise, but decisions in orbit are immediate and final. It is in these moments that trust, in equipment, in training, in each other becomes sacred. In space, one veteran says, "You don't rise to the occasion, you fall back on your preparation." Yet amid all the technical precision, there are moments that transcend science. Watching the sunrise over the Pacific, the astronauts see 16 dawns and 16 dusks every Earth day. The colors shift from indigo to gold to crimson in minutes, painting the world anew each time. It is a reminder that while spaceflight may be a triumph of engineering, it is also a meditation on beauty. As days blend into weeks, the crew adapts. Floating becomes second nature. Work becomes rhythm. The planet below turns endlessly, unaware of the fragile outposts circling above. For those living here, the boundaries between human and machine blur. They are both explorers and experiments, subjects and scientists. Their lives are a testament to what it means to live on the edge of possibility. But for all the glory of orbit, every astronaut knows it is temporary. The mission will end. The return to gravity, to Earth, is inevitable. And the thought of re-entry, with its fire and chaos, lingers in the back of every mind. For now, though, they are content to drift, to observe, to exist in this rare equilibrium between heaven and home. They have crossed the line, that invisible frontier separating the possible from the unimaginable. And once you've seen Earth from this height, nothing will ever look the same again. Part 4. The fragile world below. There is a moment, known to every astronaut, when the mission falls silent, when the hum of machinery fades to background noise, and the view through the cupola window consumes everything. It is the moment when Earth reveals itself not as a map or a nation, but as a living, breathing world. Floating 400 kilometers above it, you see no borders, no politics, no divisions. Only light, shadow, and a fragile shimmer of blue, the thin membrane of air that keeps everything alive. That fragile layer, no thicker than a child's fingernail against the vastness of space, is all that separates life from vacuum. From orbit, it glows like a halo. Astronauts describe it with reverence. A blue curve that fades into darkness so abruptly it feels like an illusion. Some compare it to an eggshell, others to the glass of a soap bubble. But all agree on one thing. From up here, the planet looks impossibly delicate. Looking down, the world feels both eternal and heartbreakingly temporary. Forests stretch like veins across continents. Rivers gleam like silver threads. Thunderstorms flash in slow motion, their lightning illuminating entire weather systems at once. From this height, beauty and destruction coexist. You can see the scars of wildfires, the gray haze of pollution, and the slow spread of deserts where green once lived. And yet, amid the chaos, there is order, an equilibrium that somehow endures. Chris Hadfield once said, "When you see the thinness of the atmosphere, you realize how fragile it all is, and how connected we are." Many astronauts echo the same sentiment, a sense of guardianship. They return home transformed, unable to look at the world without remembering how vulnerable it appeared from orbit. The term for this shift is the overview effect, a profound cognitive change that comes from seeing Earth as a single borderless system hanging in the endless black. Every astronaut experiences it differently. For some, it's a spiritual awakening, a realization that the planet is not ours to own, but ours to protect. For others, it's a haunting reminder of what we stand to lose. As one cosmonaut described, you look out the window and you see a storm the size of Europe. Then you turn your head and there's absolute black. That's it. Our entire home, surrounded by nothing. The station's windows become confessionals. Crew members float silently, staring down at the clouds for hours, watching continents roll by beneath them. They talk about the color of cities, the reddish glow of Cairo, the emerald coasts of Australia, the deep sapphire of the Pacific. They notice how human light clusters like constellations, how each glowing web marks both our brilliance and our dependence on one another. From orbit, even conflict seems trivial, a flicker of fire on a sphere too small to contain our divisions. Then there are the nights, vast oceans of darkness where no light burns. Over the Sahara, the void is absolute. Over the poles, auroras twist in ghostly green ribbons, silent yet full of power. They seem alive, like spirits guarding the planet's edge. Cameras cannot capture their movement, the slow pulse of color that dances to the rhythm of the solar wind. To witness them from space is to see Earth breathing. It's not uncommon for astronauts to weep during their first full view of home. The emotion is overwhelming, not because of fear, but because of perspective. Up here, time feels different. The station circles the planet every 90 minutes. 16 sunrises, 16 sunsets, every Earth day. You can see a thunderstorm move across Africa. Then an hour later, watch dawn spread across the Pacific. The planet turns endlessly, unaware of the watchers orbiting above. You begin to understand that everything, every storm, every war, every dream, happens within that fragile, glowing shell. And with that understanding comes responsibility. Astronauts speak often about returning to Earth with a sense of urgency, to protect the world they saw from above. From space, climate change isn't a theory, it's visible fact. Glaciers retreat, river deltas shift, forests shrink. The patterns are subtle but undeniable. You can see the planet changing, one ESA astronaut explained. You see what we're doing to it, and it's impossible to unsee. In orbit, there's also an awareness of silence, a kind of cosmic humility. The universe beyond the windows is not waiting for us. It doesn't care if we succeed or fail, if we live or vanish. The stars shine indifferently, the black stretches endlessly, and Earth spins alone, a tiny island of warmth in an infinite sea. And yet, somehow that indifference makes our existence more precious. Against all odds, this fragile sphere sustains life. Oceans, forests, children, laughter. It's all there, beneath that faint blue glow. Some astronauts have suggested that every world leader should see Earth from orbit before taking office, to understand, in an instant, the absurdity of division and the necessity of unity. Up here, there are no others. There is only us, a single species clinging to a single world. As the station passes into Earth's shadow, the blue fades to black, the stars emerge, and the lights of human civilization flicker on, a thin web of fire and memory across the darkness. It is both humbling and terrifying to realize how easily that light could vanish. Space changes people. It strips away illusion, ego, and scale. From this vantage point, humanity looks small, but also magnificent, capable of extraordinary things when united by purpose. The astronauts who gaze down from orbit are not just witnesses. They are messengers. They return to remind us of what we already know, but too often forget, that our world, for all its chaos and imperfection, is a miracle. And so, as they float above it, the question that began their journey takes on new meaning. If this fragile world is all we have, why do we risk leaving it? The answer lies ahead, written not in the clouds below, but in the red dust of another planet waiting beyond the void. Part 5. The machines that carry us. For all the poetry and wonder of spaceflight, nothing about it is gentle. Every mission begins with violence, controlled, calculated, and deafening. To escape Earth's gravity, a spacecraft must move faster than sound, faster than a bullet, faster than reason itself. It is an act of defiance against physics, powered by chemistry and faith. The rockets that carry us upward are not symbols of serenity. They are explosions shaped into purpose. At the heart of every launch stands a tower of metal and fire, part miracle, part machine. From the outside, rockets appear sleek, almost elegant. Inside, they are labyrinths of pipes, wires, valves, and tanks holding propellant colder than ice and hotter than any flame. They are built to do one impossible thing: lift humanity off the ground. The engineering behind them is a symphony of precision where the margin for error is measured in millimeters and milliseconds. The evolution of these machines tells the story of humanity's growing ambition. In the beginning, rockets were weapons, relics of war repurposed for exploration. The Soviet Union's R-7 missile became the first to send both satellites and humans into orbit. America's Atlas and Titan launchers, born from the same Cold War urgency, carried Mercury, Gemini, and Apollo astronauts to glory. But over time, the engines of rivalry transformed into engines of collaboration. Today, launch vehicles are built not just by nations, but by private companies pushing technology toward efficiency and reusability. The European Ariane 5, a workhorse for decades, is being replaced by Ariane 6, designed to have the cost of access to orbit. Japan's H-2 rockets lift cargo to the ISS with quiet reliability. India's GSLV systems, once considered experimental, now deliver satellites to deep space. And above them all, the new generation of rockets is rewriting the rules of what's possible. SpaceX's Falcon 9 changed the game. For the first time in history, a rocket's first stage could return from the edge of space, land upright, and be reused. It was an audacious idea that turned skepticism into applause. The first successful landing, watched live around the world, felt like witnessing the birth of a new era. A century after the Wright brothers proved flight possible, Elon Musk's engineers proved that even rockets could be recycled. Each successful return saves millions. Each failure teaches a new lesson. Now, SpaceX prepares its successor, Starship. Towering nearly 120 meters tall, it is designed to carry over 100 tons of cargo or a full crew of settlers to the Moon and Mars. Made of stainless steel, it looks less like a spacecraft and more like the embodiment of science fiction. But its purpose is deeply practical, to make space travel not exceptional but routine, to transform humanity from visitors in orbit into residents of the cosmos. Other pioneers have joined the race. Blue Origin's New Shepard rises from the Texas desert, carrying tourists briefly past the Kármán line before returning to land on the same pad. Its bigger sibling, New Glenn, aims for orbit with reusable stages and methane-fueled engines, the same technology powering SpaceX's future missions. Boeing's Starliner and Sierra Nevada's Dream Chaser promise safer rides for astronauts, while Europe and Russia work on modular, eco-friendly designs like Angara and Vega C. Each system represents not just a nation's pride, but a shared human ambition to make access to space as regular as flight. Yet, for all the talk of innovation, the truth remains: rockets are still dangerous. Every launch carries the weight of risk, the memory of disasters past. The loss of Challenger, Columbia, and countless unmanned missions haunts every countdown. Engineers design, calculate, and test, but spaceflight is never guaranteed. As one NASA veteran put it, every rocket launch is a bet against gravity, and gravity always plays to win. To minimize that risk, technology has evolved in astonishing ways. Modern rockets use engines that can throttle, pivot, and even relight in mid-flight. Guidance systems once powered by analog computers now rely on AI-assisted algorithms. 3D printing has revolutionized manufacturing, allowing entire rocket chambers to be built as a single piece, reducing weak points and costs alike. In testing facilities, engines roar to life in controlled infernos, each second of fire representing years of design. The sound is not just loud, it's physical. It shakes the ground, rattles bones, and reminds everyone watching that this is what it takes to leave Earth. But the brilliance of rocketry doesn't end at launch. It extends to orbit, where booster stages burn back through the atmosphere, guided by onboard computers with the precision of a falling feather. Cameras stream live footage of descent, the horizon tilting as grid fins steer the falling core toward its landing pad. The moment the engines reignite for the final burn, the world holds its breath. Then, dust, flame, and silence. Perfect landing. Applause erupts, not out of nationalism, but awe. Humanity has learned to tame fire and teach it to come home. Beyond the practical, there is poetry in these machines. They are bridges built from fuel and faith, connecting the ordinary to the extraordinary. Each bolt, each panel, each line of code is a declaration that we refuse to be confined to one planet. When a rocket launches, it doesn't just carry satellites or science. It carries our collective belief that we belong among the stars. And yet, every ascent leads to the same question that humankind has asked since the dawn of exploration. Once we can reach space easily, what then? If rockets make the cosmos accessible, what responsibility comes with that access? The answers lie not in the engines themselves, but in the missions they enable. For now, these machines carry our hope, upward through clouds, beyond the blue, and into the black. Each launch marks another heartbeat in humanity's climb toward the future. The fire beneath them is our courage made visible. The next step is not just to fly higher, but to go farther. The destination is no longer Earth's orbit. It's another world entirely. Part 6. The road to Mars for more than half a century. The moon has been humanity's greatest achievement, and its unfinished promise. We went there, we walked its silent plains, and then we turned back. But ever since that last footprint faded into the dust, one question has echoed through every laboratory, control room, and space agency. What comes next? The answer, whispered at first and now spoken with conviction, is Mars. The red planet has haunted our imagination for centuries. To the ancients, it was the god of war. To scientists, it became the mirror of Earth, dry, cold, and distant, but eerily familiar. Through telescopes and satellites, we've seen its canyons deeper than the Grand Canyon, volcanoes taller than Everest, and polar caps that expand and shrink with the seasons. It looks close enough to touch, yet impossibly far away. The dream of walking on Mars has evolved from fantasy into blueprint. NASA's Artemis program, the next chapter after Apollo, is designed not just to return humans to the moon, but to use it as a testing ground, a place to rehearse for Mars. Artemis will send astronauts to the lunar South Pole, where they'll live for weeks at a time, harvesting water ice, building habitats, and learning how to survive off-world. The lessons from the moon, how to extract resources, repair systems in vacuum, and operate far from Earth, are all pieces of a larger puzzle. How to sustain life on another planet. At the center of this ambition is Orion, NASA's next-generation spacecraft. Unlike the Apollo capsules, Orion isn't designed for short trips. It's built for deep space, capable of carrying a crew to lunar orbit and beyond, protected from radiation and micrometeoroids by advanced shielding. Its counterpart, the Space Launch System, SLS, is the most powerful rocket ever constructed. When it fires, it produces nearly 9 million pounds of thrust, enough to send humans farther from Earth than ever before. Each test flight, each ignition, feels like a rehearsal for destiny. Yet NASA isn't alone on this road. The European Space Agency contributes modules, the Japanese provide cargo, and Canadian Robotics, the next generation of the famed Canadarm, will build and maintain Gateway, a space station in lunar orbit. Gateway will act as both laboratory and harbor, the halfway point between Earth and Mars. From there, humanity will take its first true interplanetary step. But the scale of the challenge remains staggering. A mission to Mars is not a journey of days, but months. At its closest approach, the planet lies more than 55 million kilometers away. Communication delays stretch to 20 minutes each way, meaning that astronauts must make critical decisions without help from Earth. Every system, air, water, power, food, must function perfectly, self-sufficiently, and indefinitely. There are no rescue missions in deep space. To prepare, engineers and scientists have begun constructing analog habitats on Earth, Mars in miniature. In the deserts of Utah, in the Arctic, even inside volcanoes in Hawaii, small crews live for months under isolation, simulating Martian conditions. They grow food under artificial light, recycle air, and test 3D printed shelters made from local materials. Each simulation reveals new obstacles: radiation exposure, psychological strain, mechanical fatigue, and each failure brings us closer to understanding how fragile survival can be. Radiation is perhaps the greatest enemy. Unlike Earth, Mars has no global magnetic field and only a whisper of an atmosphere. Cosmic rays and solar particles would bombard the human body unprotected. Engineers propose solutions: underground habitats, regolith shielding, or hydrogen-rich materials to absorb radiation. Even then, the risks are enormous. A single major solar flare could be lethal. Astronauts will live knowing that every sunrise on Mars brings both wonder and danger. Propulsion is another frontier. Chemical rockets can take us there, but not efficiently. A 6 to 9 month journey is long enough for equipment to fail and the body to weaken. That's why new systems, nuclear thermal propulsion, ion drives, and plasma engines are under study. The goal is to cut travel time in half to make interplanetary flight not just survivable, but sustainable. Each prototype brings us closer to a reality once reserved for science fiction. Private industry now drives much of this momentum. SpaceX's Starship aims to transport cargo and humans to Mars using refueling depots in orbit. Musk speaks of building cities on the planet, self-sufficient colonies that could thrive even if Earth faltered. Many dismiss it as optimism turned obsession, but his engineers treat it as a solvable equation. Every test flight, every explosion on the launch pad is another lesson in iteration. Failure, for them, is simply progress in disguise. Meanwhile, other nations prepare their own pieces of the puzzle. China's Tianwen-1 mission has already placed a rover on Martian soil. Russia and Europe plan joint missions to retrieve samples. India's scientists are designing orbiters and landers that prove ingenuity isn't confined to superpowers. Humanity's race to Mars is no longer a competition. It's an evolution. Yet behind the calculations and engineering, a deeper question remains: why Mars? Why risk everything to reach a planet that seems determined to reject life? The answer, perhaps, is as old as exploration itself. Mars is not a refuge. It's a mirror, a reminder of what we could become and what we could lose. Its barren deserts may one day teach us how to protect the oasis we already have. Standing on its red horizon, a human would see a faint blue star in the sky, Earth, distant and small. From there, everything we've ever known would fit behind a single outstretched thumb. That thought alone captures the essence of this journey. We are not escaping our planet. We are expanding our understanding of it. The road to Mars is paved with mathematics, courage, and imagination. It is the culmination of centuries of looking upward and wondering. But even as the technology advances, one truth endures. No machine can guarantee success. The final test will not be of metal or fuel, but of will, the human capacity to endure the unknown. And so, as the countdown to our first interplanetary voyage continues, one can almost hear the echo of those who first gazed at the night sky in awe. They could not have imagined that one day, their descendants would not only reach the stars but dream of calling another planet home. The journey has begun. The question is no longer if we can reach Mars, but who will take that first step, and what will it mean when we do? Part 7, Life on the Red Planet, the first human footprint on Mars will be more than a mark in the dust. It will be the beginning of an era where humanity no longer belongs solely to Earth. But before that step can happen, the challenge is not how to arrive on Mars, but how to stay. Survival on the Red Planet is not an act of conquest. It's an act of endurance. Mars is both breathtaking and brutal. The sky glows in shades of butterscotch, and the horizon seems endless, yet every element of the environment is hostile. The atmosphere is 96% carbon dioxide, far too thin to breathe and far too weak to shield against radiation. Temperatures can plunge to minus 120 degrees Celsius at night. Dust storms can blanket the entire planet for months, obscuring sunlight and choking solar panels. And then there's the isolation, a loneliness so vast it makes the vacuum of space feel familiar. The first crews to land will live not on Mars itself, but within it. Their habitats will likely be buried beneath layers of regolith, Martian soil compacted into a natural shield against radiation and micrometeorites. Above ground, they'll look like domes of glass and alloy. Beneath, there'll be networks of tunnels, laboratories, and life support systems humming constantly to maintain an atmosphere as thin as trust. Every breath, every sip of water, every calorie will depend on technology functioning perfectly. Life support will recycle carbon dioxide into oxygen through electrolysis. Water will be extracted from the planet's ice deposits or chemically produced from hydrogen brought from Earth. Nothing can be wasted. Even sweat, breath, and waste will be filtered and reused. In this world, the concept of throwing something away will no longer exist because there will be nowhere to throw it. Food will not come from shipments. Supply lines across tens of millions of kilometers are impossible to sustain. Instead, astronauts will grow crops in hydroponic systems using LED lights to mimic sunlight. Early experiments on the International Space Station, growing lettuce, radishes, and zinnias, have already proven that plants can adapt to microgravity. On Mars, gravity is about 1/3 of Earth's, just enough for roots to grow downward and stems to rise upward. Yet every plant will be precious. In the red dust, a single green leaf will be more valuable than gold. Psychologically, life on Mars will be unlike anything humanity has ever endured. Imagine waking up each morning knowing that the nearest human settlement is millions of kilometers away. That help, if it ever comes, would take months. Days will be long. Sunsets blue, skies tinted with iron. The silence will be absolute. Even on Earth's most remote frontiers, Antarctica, the ocean floor, there's the knowledge of home above or beyond. On Mars, there is only the horizon, endless and indifferent. Isolation has always been humanity's most profound teacher. Astronauts aboard the ISS experience it in short bursts, 6 months, maybe a year, with constant communication from Earth. But Mars will change that. The 20-minute delay in radio signals means conversations become monologues, replies echoes of the past. A joke sent to Earth might return as laughter 20 minutes too late. Birthdays will be celebrated in advance or long after. Loneliness will not be a condition, it will be a companion. To prepare, psychologists study polar research teams and submarine crews. They observe how humans adapt to monotony, confined spaces, and constant proximity. They know that personality may matter as much as intelligence or skill. The first Martians must be patient, creative, and emotionally resilient. A single argument in a confined habitat could ripple into catastrophe. As one behavioral scientist puts it, the hardest environment to survive isn't outside the base, it's inside it. Despite the challenges, the rewards are profound. Every experiment conducted on Mars will deepen our understanding of both planets, revealing how water once flowed across its surface, how its climate changed, and whether life ever began there. Even a single microbe discovered in the Martian soil would rewrite biology itself, proving that life is not unique to Earth but a cosmic inevitability. In that sense, the mission is not just exploration, it's existential inquiry. The base itself will be a marvel of design. Pressurized tunnels will connect living quarters, laboratories, and greenhouses. 3D printers will manufacture tools and spare parts from local materials, using regolith mixed with polymer or melted ice as building feedstock. Power will come from a combination of solar arrays and compact nuclear reactors, capable of running for years without maintenance. Every component will be modular, replaceable, redundant. In the architecture of survival, there can be no weak links. But beyond the science and engineering lies something more human, the idea of home. The first settlers will decorate their habitats with small reminders of Earth. Photos, music, small trinkets, a flag pinned to the wall. They'll invent rituals, weekly video messages, shared meals, moments of silence. The effort to create normal in a world that has none will be what keeps them sane. In time, children may be born there. The first generation of humans who will never see Earth except as a distant star. They will grow under lower gravity with lighter bones, different circulation, new instincts. To them, Mars will not be a frontier, it will be home. And perhaps one day, they'll look at the blue point in their sky and wonder why their ancestors ever left it. Every great civilization began with a settlement, a handful of humans choosing to stay where survival seemed impossible. If we succeed on Mars, it won't be because of technology alone, but because of something deeper, the human refusal to surrender to isolation. The red planet may not welcome us, but it doesn't need to. Survival will be our introduction, endurance our conversation. In time, perhaps, Mars will answer back. Not in words, but in the quiet rhythm of footsteps across its dust. And when that first colony breathes its first self-made air, humanity will have crossed not just space, but an existential divide. We will have become a multi-planet species. Yet even as we build this new world, one question will remain. A whisper from the blue planet left behind. Will we remember where we came from? Part 8. The search for life long before humans dreamed of walking on Mars. They wondered whether something or someone was already there. The red planet has been both a canvas for our fears and a mirror for our hope. Once imagined as a world of canals and civilizations, later dismissed as barren and dead, Mars has become something even more mysterious, a question that refuses to die. Was there ever life on Mars, and if so, what does that mean for us? Every rover, lander, and orbiter sent to Mars has carried that question as its secret cargo. In the 1970s, NASA's Viking missions performed the first experiments designed to detect life. The results were inconclusive chemical reactions that mimicked biology but stopped short of confirming it. For decades afterward, the planet seemed silent. But silence, scientists learned, does not mean emptiness. Then came the next generation of explorers: spirit, opportunity, curiosity, perseverance. They weren't looking for aliens. They were looking for evidence of conditions that could support life: water, energy, organic molecules. And one by one, they found it. Ancient riverbeds carved through the Martian crust. Clay minerals that form only in water. Sedimentary layers built over eons. In the Jezero crater, Perseverance uncovered rocks that once lay at the bottom of a long-vanished lake. There, trapped in the mineral lattice, may lie the chemical fingerprints of life that ended billions of years ago. On Earth, where water flows, life follows. From volcanic vents to frozen glaciers, even in the darkest depths of the ocean, microbes endure. If Mars once had rivers, lakes, and rain, could it have nurtured something similar, simple, microscopic, resilient? The idea is both thrilling and humbling. It suggests that life is not rare, but inevitable wherever the conditions allow. The search now reaches into the smallest details, isotopes of carbon, traces of methane, and the textures of rock. Methane, in particular, has become a tantalizing clue. On Earth, most methane comes from biology. When orbiters and rovers detect it on Mars, even in faint wisps, scientists take notice. It appears, vanishes, and reappears again, as if the planet itself is breathing. Some argue that geological reactions deep underground may explain it. Others whisper of something more, ancient microbial colonies still clinging to existence beneath the surface, shielded from radiation and time. Future missions aim to find out. The ExoMars rover, a joint venture between the European Space Agency and Roscosmos, will drill deeper into the Martian soil than any previous probe, up to 2 meters below the surface, where traces of preserved organics may survive. NASA and ESA also plan the most ambitious collaboration in planetary science, the Mars Sample Return. Over the next decade, robotic missions will collect core samples, launch them from the Martian surface, and bring them back to Earth for analysis. Within those vials of dust may lie the first fossil record beyond our world. But the search for life is more than a scientific pursuit. It is a philosophical reckoning. If we find proof that life existed, even as microbes, it will redefine our place in the universe. Humanity's greatest solitude, the belief that we are alone, would vanish. Life would no longer be an anomaly but a pattern. And if it happened on Mars, why not elsewhere? Europa, Enceladus, Titan, each with oceans hidden beneath ice, could be living worlds waiting to be discovered. Yet the discovery of Martian life would raise questions as daunting as the ones it answers. Did life on Mars and Earth share a common origin? Could meteorites that traveled between the planets have carried microbes, seeding both worlds? If so, then life, even intelligent life, may not begin in isolation. It may spread, like fire, across space and time. We may already be the descendants of an ancient cosmic migration. There is also the darker question: what if we are about to contaminate the very world we seek to study? Every spacecraft, no matter how sterilized, carries traces of Earth's biology. A single spore, surviving in the cracks of a rover, could confuse future tests or worse, overwrite the fragile record of native Martian life. For that reason, planetary protection has become a discipline of its own. Scientists debate how to balance curiosity with caution, exploration with preservation. It's a paradox. To search for life, we must risk destroying its evidence. Beyond the science, the human imagination still lingers on the possibility of something more. We've spent centuries projecting ourselves onto Mars, from H.G. Wells's Invaders to Ray Bradbury's Poets. Even now, as robots roll across its deserts, we wonder what might once have looked back. Were there organisms that built structures, evolved intelligence, left ruins buried in sand? The rational mind says no. The dreamer in us remains unconvinced. In recent years, high-resolution images have revealed anomalies, rock formations that resemble relics, symmetrical ridges that some claim look artificial. NASA explains them as geology, erosion, pareidolia, our brains seeing patterns in randomness. But the fascination endures, perhaps not because we expect to find monuments or messages, but because we want to believe that the universe has more than one storyteller. If Mars does hold life, past or present, the implications will extend beyond science. Religions, philosophies, and politics will all feel the tremor. The discovery will not diminish humanity, it will enlarge it. It will remind us that creation is not confined to a single planet. And if we fail to find life that too carries meaning, it would underscore how rare, how precious our own existence truly is. In either case, the search itself becomes a form of prayer, a way of asking the universe if we are alone, and listening carefully for the answer. Every sample, every signal, every grain of dust examined under a microscope brings us closer to that moment of truth. And perhaps, when we finally find what we are looking for, a fossilized cell, a chemical signature, a pattern in the rock, we will realize that the question was never just about Mars. It was about ourselves, about understanding why, against impossible odds, life continues to reach outward, to search, to hope. Because in the end, the search for life on Mars is not about finding them. It's about understanding us, the species that refuses to stop asking the universe who else might be listening. Part 9. Echoes across the planets. When humanity sends its gaze outward, the echo always returns home. Every discovery made on Mars reverberates back to Earth, reshaping not only our science but our sense of identity. The red planet has become a mirror that reflects our ambition, our fears, and our longing for connection. It's more than a destination. It's a reflection of who we are becoming. The images beamed back from rovers like Perseverance and Curiosity don't just fill scientific journals. They fill living rooms. They remind billions that, right now, somewhere millions of kilometers away, a small machine built by human hands is crawling across alien ground, whispering data into the void and being heard. The world watches not because of curiosity alone, but because each photograph, each panorama, each sound recording feels like a glimpse into our collective future. The first time humankind heard the wind of another world, a thin, ghostly hiss captured by a microphone on Mars, it wasn't just sound. It was proof that the alien could be intimate, that other worlds are not silent, but waiting for us to listen. Governments, corporations, artists, and philosophers all respond in their own ways. Nations invest in planetary science programs, seeing in Mars a stage for technological prestige and cooperation. Private companies, driven by the promise of new frontiers, develop life support systems, energy networks, and construction technologies that could one day be used on both planets. Poets write about exile and belonging. Filmmakers imagine the red deserts as metaphors for human perseverance. Even children, tracing the outlines of Martian craters in textbooks, begin to think of the universe not as unreachable, but as the next neighborhood. Mars has become a cultural phenomenon, a bridge between hard science and human imagination. In the past decade, the planet has appeared in countless films, novels, and documentaries. Some celebrate it as humanity's second home. Others warn against repeating the mistakes we made on Earth, the exploitation, the division, the illusion of ownership. The phrase colonizing Mars is being replaced with settling, inhabiting, or even coexisting. The vocabulary itself is evolving as we begin to understand that exploration cannot mean domination. Politically, the idea of Mars has forced nations to reconsider the concept of borders. No single country can claim it, not legally, not morally. The Outer Space Treaty of 1967 forbids sovereignty beyond Earth, declaring space the province of all humankind. Yet, in an age where corporations wield power rivaling governments, that ideal faces new tests. Who will control the resources, the water, the minerals, the data? Who decides what kind of society will be born on another world? These are not distant hypotheticals. They are the foundation of the next century's geopolitics. The United Nations now holds regular discussions on planetary ethics, debates once confined to science fiction. Should Mars be terraformed to resemble Earth, or preserved as a pristine ecosystem, even if lifeless? Should humans alter another planet to survive, or adapt themselves instead? The line between exploration and interference grows thinner with every mission. For the first time, our moral imagination must expand to include more than one planet. Back on Earth, Mars has become an accelerant for innovation. Technologies designed for interplanetary survival, renewable energy, autonomous robotics, closed-loop water systems are transforming life here. Engineers perfecting Mars habitats develop methods to build sustainable homes in deserts and disaster zones. Agricultural researchers studying hydroponics for the Martian soil apply their findings to drought-stricken regions. What began as preparation for another world becomes salvation for this one. In a way, Mars is teaching humanity how to live on Earth again. And yet, there is unease. The idea of leaving our planet carries an unspoken shadow, the fear that we are escaping responsibility. Some critics argue that space colonization is a distraction from the crises we've created here. Climate change, inequality, conflict. Why reach for the stars when our home is burning? Others counter that exploration has always been our way of survival, that the same drive that sends us outward is the one that might save us inward. Perhaps both are true. Every generation inherits the dreams of the one before it. The Apollo program was born in the shadow of war. The Mars program rises in the shadow of climate collapse. Both carry the same question, not just can we go, but should we? Mars has forced humanity to look not only outward, but inward, to see our planet as others might see it. Fragile, alive, worth saving. There is also a spiritual resonance. Religious leaders and philosophers have begun to reinterpret creation through the lens of cosmic plurality. If life exists elsewhere, does it share the same origin, the same consciousness, or are we witnessing the universe expressing itself in countless forms? In churches, temples, and classrooms, conversations once confined to science fiction now feel like theology. And in all of it, the science, the politics, the art, a quiet realization is taking root. The journey to Mars is not just a voyage of expansion, but of reflection. Every step we take away from Earth teaches us something about what it means to be human. When future historians write about this age, they may not call it the space race. They may call it the mirror age, the time when we finally saw ourselves, small but significant, reflected in the surface of another world. In the red dust, we are beginning to understand that exploration is not an escape. It is an echo. The further we go, the clearer we hear it, the sound of our own heartbeat reverberating across two planets. Part 10. The price of expansion. Every great leap in human history has come with a cost. The voyage to Mars, though wrapped in optimism and innovation, is no exception. For all its promise of discovery and destiny, interplanetary expansion demands a reckoning with nature, with technology, and with ourselves. The stars may beckon, but every ascent carries shadows. The first cost is physical, a toll on the human body that no training can fully prepare for. Space changes us. In zero gravity, muscles weaken, bones dissolve, vision blurs, and the heart reshapes itself under new conditions. Astronauts returning from long missions often struggle to walk for days. On Mars, where gravity is 1/3 that of Earth's, the body may adapt, but it will never be the same. Generations born there might evolve lighter frames, slower circulation, different physiology altogether. Someday, a child of Mars may find Earth's gravity crushing, a planet too heavy to call home. Then comes the cost to the mind. Isolation gnaws at the psyche, even for the strongest. Studies on the International Space Station show that 6 months in confined quarters can blur emotional boundaries, distort perception, and weaken motivation. On Mars, where communication delays stretch minutes into eternities, loneliness becomes more than a feeling. It becomes a force of nature. The human mind, designed for connection, will be tested as never before. Each colonist will live knowing that a single mistake could doom them all, and that rescue will never come. Yet, the deeper cost may be ethical. As humanity prepares to set foot on another planet, we face questions that cannot be answered by science alone. What right do we have to alter a world that existed in silence for billions of years? If life is found there, even microbial, do we preserve it or prioritize our survival? The act of colonization, even under noble intentions, carries echoes of our past, of conquest disguised as exploration, of curiosity entangled with control. We tell ourselves this time will be different, but history has a way of following us, even into the stars. Terraforming, the grand vision of transforming Mars into an Earth-like world, embodies this dilemma. The idea is seductive. Melt the polar ice caps, release trapped carbon dioxide, thicken the atmosphere, and let plants grow under a warm, blue sky. but it would require centuries of effort and energy on a scale we've never attempted. The ethical question is staggering. Should we reshape another planet simply because we can? Or should Mars remain Mars? A reminder that not every world exists for human comfort. The environmental cost, too, cannot be ignored. Rockets burn immense amounts of fuel, their launches releasing tons of carbon and soot into the upper atmosphere. As missions multiply, so does the impact. The pursuit of other worlds risks harming the one we already have. Ironically, the dream of saving humanity through space exploration could accelerate the damage to Earth itself. Engineers now race to develop greener propellants, reusable systems, and cleaner launch infrastructure, not just out of necessity but conscience. Financially, the price of expansion is measured in trillions. Governments face growing tension between funding cosmic ambitions and addressing terrestrial crises. Hunger, inequality, environmental collapse. Critics argue that the billions spent on Mars could transform life on Earth instead. Supporters counter that space exploration drives innovation, creating technologies that eventually benefit everyone. Both sides are right, but the debate reveals something profound. The question of space is no longer about capability, it's about morality. And there is another cost harder to quantify, the one paid in meaning. For centuries, the night sky has been humanity's great mystery, a canvas for myth and wonder. What happens when we reach it? When the unreachable becomes routine, when Mars has airports and traffic, when the stars are no longer distant but domestic. The romance of the cosmos may fade, replaced by bureaucracy and familiarity. Exploration, once sacred, could become commerce. In chasing the infinite, we risk reducing it to the ordinary. Philosophers warn of a deeper danger, that by spreading across the solar system without resolving the divisions on Earth, we might simply export our flaws, greed, inequality, indifference. If humanity colonizes Mars without learning to live in peace on Earth, we will have expanded our reach, not our wisdom. The challenge of the future is not just to inhabit new worlds, but to evolve into a species worthy of them. Still, for all these costs, humanity continues to climb. It is in our nature to push boundaries, even when the price is high. Perhaps that's what defines us, not perfection, but persistence. Every civilization that dared to cross an ocean or scale a mountain knew risk and loss. Yet they sailed anyway, believing that what lay beyond was worth the sacrifice. The journey to Mars will test not only our technology, but our ethics, empathy, and endurance. It will ask whether progress must always mean conquest, and whether exploration can coexist with humility. It will demand that we measure success not by how far we travel, but by how responsibly we arrive. In the end, the price of expansion may not be paid in currency, but in transformation. The first humans to stand beneath the Martian sky will not just see a new world. They will see themselves, reflected in red dust and silence. And perhaps, in that moment, they will understand that exploration is not about leaving Earth behind, but about learning to cherish it more deeply. Because every step we take away from home reminds us how rare home truly is. Part 11. The turning point. Every age of exploration has its moment. The instant when mystery becomes revelation, when discovery shifts from speculation to certainty. For Mars, that moment arrived quietly, not with fanfare or fireworks, but with data. A faint signal, a pattern in dust, an anomaly too persistent to ignore. It began as a whisper from the red planet and ended as a truth that changed everything. It started with perseverance. While collecting sediment cores in Jezero crater, the rover's instruments detected something unusual, organic molecules with a complexity far beyond expectation. The readings were faint, fragmented, ambiguous. At first, scientists dismissed them as contamination, noise in the data. But then the patterns repeated, identical structures appearing in multiple distant samples. Coincidence, perhaps, but coincidences don't replicate across kilometers of terrain. The confirmation came months later from orbit. The Trace Gas Orbiter detected a narrow plume of methane rising from a fissure in the crater's rim. It wasn't the first methane detection, but this time, it fluctuated in perfect correlation with the rover's location. Wherever Perseverance drilled, the methane pulse followed, as though the planet itself were responding. Within days, every mission turned its focus toward Jezero. The European ExoMars team recalibrated instruments. NASA's analysts worked around the clock. A special task force convened between Houston, Darmstadt, and Tokyo, 3 continents united by a single, trembling question. Is it possible? In early 2031, after weeks of verification, the data became undeniable. The isotopic ratios of carbon and hydrogen in the samples could not be explained by purely geological processes. The organic chains were complex, branching, repeating, suggestive of metabolism. Not life as we know it, perhaps, but life nonetheless. Fossilized microbial structures, billions of years old, preserved in Martian clay. Humanity had found its echo in another world. The announcement came not from a president or prime minister, but from a scientist, Dr. Amina Reyes, lead astrobiologist for the mission. Standing before the world, she said simply, "We have found evidence that Mars once lived." The sentence lasted 5 seconds. Its impact would echo for centuries. Religions paused. Governments faltered. Philosophers wrote furiously. Overnight, humanity's deepest solitude dissolved. We were no longer alone, and perhaps never had been. The discovery reshaped everything. Universities launched new disciplines: comparative biology, astroecology, interplanetary ethics. Theologians debated whether life beyond Earth meant multiple creations or a single, universal genesis. Economists and politicians redefined their ambitions, suddenly aware that the universe was not empty real estate, but a living continuum. But not all reactions were wonder and unity. Some feared what might come next. If life had existed once, could it exist still? Could dormant microbes awaken, adapting to human presence? Quarantine protocols tightened. Mars missions were suspended pending safety reviews. The very dream of colonization collided with the moral question of preservation. The United Nations convened an emergency summit. Its topic: planetary protection and responsibility beyond Earth. For the first time, the words ecology and cosmos shared the same stage. The debate split the world. One faction argued for containment to seal off Jezero crater, study it remotely, and treat Mars as a planetary sanctuary. The other insisted on continuation, exploration, expansion, and human presence as the next logical step. The divide was not between nations, but philosophies, protectors versus pioneers. The tension reached its peak when a private company, one of the new space industrial powers, announced plans to land an autonomous mining unit within 200 kilometers of the discovery site. Scientists warned of contamination. Activists protested. Governments hesitated. For the first time, Mars became not just a scientific question, but a political battlefield. And then came another revelation. While studying the isotope patterns in the ancient carbon compounds, researchers noticed something subtle, a variation in chirality, the molecular handedness of the samples. On Earth, life uses one consistent orientation for amino acids. The Martian samples used the opposite. It was life, but not our life. That realization hit harder than the discovery itself. It meant life didn't just happen once. It happened twice, independently, within the same solar system. The odds were no longer astronomical. The universe, by implication, was teeming. Suddenly, the question wasn't, are we alone? It was, what else is out there? And how often does it happen? Astronomers redirected telescopes toward exoplanets with renewed urgency. Funding surged for biosignature detection missions. The search expanded from our neighbor to the galaxy. Every red dot in the sky became a possibility. Every silence a prelude to sound. Back on Earth, the social impact deepened. Music, art, and literature flourished with cosmic themes. Faith found new footing in humility. For many, the discovery was proof not of our uniqueness, but of our belonging, that life is not an exception, but a rule written in starlight. And yet, amid celebration, a quiet fear grew. If life arises wherever it can, then intelligence might, too. And if evolution is universal, we may not be the first, nor the last, to look outward. Mars had given us evidence of life's beginnings. Somewhere, perhaps, another world held evidence of its maturity. For now, the fossils remain silent. The microbes, long extinct, offered no warning, no wisdom, only the undeniable truth that the universe does not wait for permission to create. In that silence, humanity reached a turning point. Exploration was no longer about expansion. It was about connection. We were part of a larger story, one that began long before us and will continue long after. And in that realization, something shifted. The stars no longer felt distant. They felt inevitable. Part 12, the awakening the moment humanity confirmed that Mars had once lived. The universe itself seemed to expand. It wasn't the planet that changed, it was us. The discovery tore open a veil that had covered human imagination for millennia. For the first time, we knew that life did not belong to Earth alone. It was not an accident, not a miracle unique to one blue sphere. It was a pattern, a signature written into the fabric of the cosmos. At first, there was celebration. Streets filled with people watching holographic broadcasts of Jezero Crater, where the fossilized microbes had been found. Schools rewrote textbooks overnight. Children drew red planets with green swirls and tiny organisms, labeling them our cousins. The global mood was electric, a shared awe that transcended nations. For one brief moment, humanity was united by wonder rather than war. Then came the silence that always follows revelation, the collective pause when excitement gives way to comprehension. What did it mean to live in a universe alive? What responsibilities came with that knowledge? Philosophers compared it to the Copernican revolution, when humanity realized it was not the center of creation. Only this time, the revelation was deeper. We were not alone in being alive, and perhaps not alone in being aware. The discovery reshaped every discipline. Biologists began mapping universal evolution, studying how different environments could give rise to similar biological solutions. Engineers designed new sensors to detect subtle chemical traces in alien atmospheres. Even artists changed course. Painters replaced portraits with planetary landscapes, poets with cosmic metaphors. The language of humanity began to stretch toward the infinite. But the most profound transformation was not scientific, it was spiritual. Faiths that had stood divided for centuries found common ground in humility. Theologians debated not whether God created life elsewhere, but how vast creation must truly be. Temples projected images of the Martian landscape alongside sacred texts, interpreting the fossilized microbes as another form of divine expression. For once, science and spirituality spoke not as rivals, but as partners in awe. In the years that followed, the search for life accelerated beyond imagination. A new generation of missions launched, not to colonize, but to connect. The Astra Initiative, an unprecedented collaboration among 30 nations, united under one mission: to explore life throughout the solar system while preserving its integrity. The motto was simple: discover, but do no harm. Advanced probes descended into the icy plumes of Enceladus, the subsurface oceans of Europa, and the methane lakes of Titan. Each mission carried lessons learned from Mars: sterilization, containment, reverence. Humanity had learned restraint, a quality rarely associated with exploration. Every discovery was now treated not as conquest, but communion. On Mars itself, Jezero Crater became a sanctuary. The excavation site was sealed under a transparent dome, not for exploitation but preservation. Astronauts who visited the site spoke of it in whispers, as though entering a cathedral. They described the fossils as fragile threads connecting two worlds, remnants of a life that had ended before ours began, yet somehow still part of our story. And then came the next revelation, smaller in scale but far more immediate. In a remote corner of Mars, near the base of Olympus Mons, a robotic sensor registered faint thermal fluctuations underground. The readings were irregular, too structured to be random, too consistent to be mechanical error. A subglacial pocket of briny water, perhaps, or something else. Within days, the global network of observatories confirmed it. There was heat. Not much, only a fraction of a degree above ambient temperature, but steady, constant, localized. Geological activity could explain it, yet the chemistry of the surrounding terrain did not match any known volcanic signature. If it wasn't purely natural, then something beneath the Martian crust was still reacting, still alive in some form. Humanity's first response was disbelief. The second was silence. Governments called for caution, scientists for patience. For months, data poured in: isotope readings, thermal maps, magnetic signatures, all inconclusive, all provocative. Slowly, the evidence pointed to the unthinkable. Microbial colonies, dormant for eons, had reawakened in a pocket of salt water sealed beneath the surface. They were not fossils. They were living. No human hand had touched them. No contamination could explain their chemistry. Life, ancient, alien, stubborn, had endured the cold of time itself. Mars had not just lived. It was living. The news reached Earth like a tremor. This was no longer about the past. It was about the present and the future. For the first time, humanity faced another form of life, not across light years, but across a mere 60 million kilometers. The boundary between the living and the cosmic dissolved. The philosophical consequences were seismic. If life had persisted there, then death was not the default state of the universe. Life was the rule, not the exception. The cosmos was not silent, only waiting for us to listen correctly. Scientists proposed an extraordinary idea: to communicate, not through language but chemistry, to send gentle pulses of light, temperature, or nutrients to see if the Martian microbes would respond. To start, perhaps, the first conversation between worlds. The proposal divided humanity once again. Some saw it as destiny, others as danger. Do not awaken what has slept for billions of years, they warned. Do not disturb what may not understand us. But the question could no longer be contained. The urge to reach out, to touch, to connect was woven into our nature. And so, in a moment that will define the next century, a small robotic probe lowered itself into the Martian fissure. It extended a sterile arm, releasing a controlled pulse of heat and light. For hours, the sensors recorded nothing. Then, as if answering across eons, a subtle chemical change registered in the nearby soil. A shift, a movement, a whisper, the unmistakable sign of biological response. It was faint, it was fragile, but it was real. Humanity had not only found life beyond Earth, it had been acknowledged. Part 13, the message beneath the dust at first. No one called it a message. Scientists are cautious with language. They measure, they verify. But the data streaming from Mars that week was unlike anything ever recorded. The chemical sensors in the fissure showed rhythmic fluctuations, sequences of carbon compounds forming and breaking apart in repeating intervals. It wasn't random. It wasn't geological. It was deliberate in a way that defied coincidence. The team at the Jezero Command Center worked in silence. Every variable was checked, every source of error eliminated. The signal remained, a pulse of molecular activity, faint, methodical, almost musical. The microbes weren't just alive, they were responding. The pattern emerged slowly, across days. For rises, a pause, 3 drops, another pause, repeating endlessly. It reminded one researcher of Morse code, another of a heartbeat. The fluctuations aligned with the probe's thermal pulses, as though the organisms were reacting not to the light itself, but to the rhythm, to the intention. News leaked before NASA or ESA could contain it. Within hours, the world was awake. Screens everywhere filled with red dust and graphs of carbon chains. Some called it communication, others coincidence. But deep down, everyone felt the same sensation, the quiet awe of being seen. For the first time in history, Earth had spoken to another form of life. And it had answered. The debate ignited instantly. Was this life intelligent or simply reactive? Could microorganisms communicate, or was humanity projecting meaning onto chemistry? The scientific community fractured into two camps: the empiricists demanding proof, and the humanists insisting that the act of response, any response, was proof enough. While the arguments raged on Earth, the probe on Mars continued its interaction. Each day it sent a calibrated pulse, light, heat, vibration. Each day the Martian microbes replied, adjusting their chemical signature in response. When the pulses stopped, so did the activity. When they resumed, the microbes awoke again. It was as if two worlds were learning each other's breath. The press called it the whisper. The name stuck. To avoid contamination, no human had yet approached the site. Everything was done remotely with robotic precision. But as the rhythmic exchanges continued, public pressure grew. People wanted to see the life that was responding to them, not through graphs, but through eyes. Scientists resisted. Politicians intervened. Eventually, compromise emerged. A human mission, strictly observational, no contact permitted. The ship that would carry them, Astrius I, launched in late 2034, a joint mission representing 17 nations. Its crew of 6 carried not weapons or flags, but microscopes, sealed containment chambers, and a single goal: to witness life awakening beyond Earth. As the spacecraft approached Mars, the crew received the latest data from Jezero. The chemical pulses had changed again, the rhythm slowing, becoming irregular. Some feared the organisms were dying. Others believed they were adapting. Either way, the sense of urgency was palpable. When Astrius I descended through the thin Martian atmosphere, its landing thrusters kicking up plumes of rust-colored dust, the world held its breath. Cameras broadcast every moment live. The crew's first words, transmitted through static, would be etched into history. We are standing on living ground. The fissure lay a few hundred meters from the landing site, a dark scar in the ochre landscape, barely visible from orbit. Under the thin sunlight, the team deployed sterilized drones and instruments. When they reached the edge of the fissure, they found crystalline frost glinting along its walls, frozen brine, shimmering faintly like veins of light. Beneath it, something pulsed. Tiny bubbles formed and vanished in patterns, symmetrical, deliberate. The temperature oscillated with impossible precision, cycling in the same rhythm the sensors had detected months before. One of the crew whispered over the open channel, "It's still talking." The team began non-invasive scans. Chemical spectra confirmed that the subsurface colony was active, generating complex organic reactions in response to electromagnetic stimulus. What no one expected, however, was what came next. During a low-frequency transmission test, meant to map conductivity through the crust, the colony emitted a sudden surge of infrared energy. The spike lasted less than 10 seconds. But in that brief moment, the surrounding instruments all registered identical fluctuations. Not random noise, but structure. Lines, intervals, repetition. When decoded into sound frequencies, the pattern formed something eerily familiar. Harmonic ratios, simple mathematical relationships, the same principles found in music, speech, and biology itself. It was communication, not in language, but in mathematics. The message, once translated into a visual graph, revealed a fractal sequence, a recursive pattern repeating at multiple scales. It mirrored the geometry of snowflakes, seashells, galaxies, and DNA. The microbes, it seemed, were echoing the fundamental patterns of nature itself. No one could say whether it was intention or instinct, intelligence or chemistry. But in that moment, the line between those definitions blurred. Humanity had not just found life, it had found resonance. Across Earth, the reaction was overwhelming. Billions watched the live feed as the first clear images appeared. A thin sheet of frost, shimmering faintly, pulsing with silent rhythm beneath a red sky. Children cried, scientists wept, religious leaders prayed. For once, the divisions of Earth seemed to fade, because beneath the dust, something ancient was breathing in unison with us. The world's languages found new words for the moment: connection, echo, kinship. But none captured the full magnitude of what was happening. It wasn't contact in the way we imagined. No voices, no lights, no ships. Just a pulse, a rhythm, a reply. Yet in that simplicity was something profound. The realization that life, wherever it exists, speaks the same truth. It strives to endure. It listens. And when the universe finally asks, it answers. Part 14. The edge of understanding the Martian pulse became the heartbeat of two worlds. For weeks, it continued, measured, rhythmic, hauntingly precise. Every oscillation of temperature, every faint shift in chemistry, every rise and fall of molecular energy was logged and transmitted to Earth in real time. The numbers scrolled endlessly across screens in Houston, Darmstadt, and Tokyo. Data scientists and linguists stared at the patterns until their eyes blurred, searching for meaning in the mathematics of another world. At first, humanity tried to translate it. We are creatures of pattern. We see language in everything. Teams fed the signal into artificial intelligence systems, transforming it into sound, color, geometry. The algorithms generated possibilities, sequences resembling prime numbers, Fibonacci spirals, harmonic scales. Some claimed the microbes were expressing structure, others argued it was coincidence. Yet beneath the noise, a symmetry persisted. It wasn't random. It wasn't static. It was evolving. On the 37th day of continuous observation, the pattern changed. The intervals between pulses lengthened, forming clusters separated by silence. Long, deliberate pauses, as if waiting for something. The Astronomy crew decided to respond. Under strict supervision, they transmitted a controlled series of light pulses into the fissure. 1, pause, 1, 1, pause, 1, 1, 1. The simplest universal message humanity knew, counting. Minutes passed. Then the Martian signal returned, repeating the same structure, but inverted. 1, 1, 1, pause, 1, 1, pause, 1. A mirror reply. The crew stared at their instruments in disbelief. There was no mistaking it. The response was not reactive. It was relational. Earth erupted. Across every continent, people stopped what they were doing to watch the replay. A pulse from humanity, a pulse from Mars, echoing back like a heartbeat shared across space. Scientists struggled for language, politicians called for restraint, poets and philosophers wept. The line between experiment and communion had vanished, but with wonder came fear. If this was communication, what were we saying, and what were we being told? Could a conversation exist without shared context? Could a species of microbes, evolved in isolation for billions of years, comprehend intention? Or were we simply witnessing the universe recognizing itself? As the exchanges continued, the pattern grew more intricate. The microbes began producing compound waves, layered responses combining frequency and amplitude. Some of the sequences resembled the harmonic ratios found in atomic structures. Others matched the electromagnetic frequencies of hydrogen, the most common element in the universe. It was as if Mars was reciting the language of creation itself. The Astronomy team, under guidance from Mission Control, initiated a broader test. They transmitted a mathematical series representing the golden ratio, a symbol of natural growth and balance. For almost an hour, there was no reply. Then the signal returned, not the same pattern, but a variation that completed the equation. The microbes had answered with symmetry. Humanity had reached the edge of understanding. Beyond this point, language as we knew it ceased to function. Philosophers began calling it the reflection principle, the idea that the Martian signal wasn't communication in the human sense, but resonance. The organisms were not speaking to us. They were responding with us, matching structure to structure, intention to intention, until distinction blurred. It wasn't conversation. It was communion, but communion carries risk. As more probes and instruments were deployed to monitor the colony, subtle changes appeared in the Martian environment. The local temperature rose slightly. The chemical composition of the soil began to shift. Radiation readings fluctuated. Some scientists feared that the interaction, however careful, was altering the fragile equilibrium. The microbes were adapting faster than expected, perhaps even learning. In emergency meetings, planetary protection officers debated halting the experiment. "We don't know what we're teaching them," one biologist warned, "or what they might be teaching us." Others argued that stopping now would be like closing a book after the first word. "We've waited our entire existence for an answer," another replied. "We can't turn away because it scares us." On the 45th day, the microbes sent a new pattern, longer, more complex, woven with alternating frequencies. When converted into a spectrographic map, it revealed something astonishing: a geometric image. At first it seemed abstract, interlocking circles and spirals, but when processed at higher resolution, the pattern formed a clear, symmetrical motif: a double helix, DNA. Not identical to ours, but unmistakably biological, a universal symbol of life recognizing life. For the first time, humanity saw a reflection of itself in the alien. It wasn't language, it was identity. The microbes, or whatever network they formed, had mirrored the essence of living structure. Somehow, across billions of years and two worlds, life had found a way to say the same thing. The realization sent shockwaves through every field of human thought. Theologians called it a divine handshake. Scientists called it the first true cross-planetary recognition. The public simply called it the answer. After that, the pulse faded. The microbes went silent, as if retreating back into their ancient sleep. The instruments registered no further fluctuations. Some mourned the silence. Others understood it differently. The Martian organisms had given their reply, not endless dialogue, but a single gesture of recognition. It was enough. Months later, when Astronomy departed Mars, its cameras captured one last view of Jezero crater at dawn. The sun, low on the horizon, cast a crimson light across the frost. In the faint shadow of the fissure, the frost shimmered once more, a slow, almost imperceptible flicker, like a final heartbeat. Back on Earth, the data from the mission filled libraries. Scientists continued to debate the meaning of the exchange, but the question of whether humanity was alone had been answered forever. The edge of understanding had been reached and crossed. What lay beyond was no longer science alone, but something deeper, something sacred. The recognition that life, in all its forms, is one conversation written across the stars.